Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's session we are going to study about certain reactions which are related to iron, aluminium and sodium. We have already studied the reactions related to calcium, magnesium and hydrogen in the previous sessions. In this session we will study all the soluble impurities in the form of iron or aluminium or sodium. That means all the soluble salts of iron, magnesium or sodium which are present in water contributing to the hardness of water, and we will try to convert them into precipitates or insoluble salts and filter out water, thus converting hard water into soft water. Reactions required for solving problems, part 3. The first one we are looking for is FeSO4. Since my SO4 is 2 minus, my Fe will be 2 plus because this 2 minus and this 2 plus will be cancelled out. That means if I have a soluble form of FeSO4 inside my water, then this FeSO4, that is 2 plus ions of Fe, will be present in the water. If 2 plus ions of Fe are present in the water, they are contributing to the hardness of water, and thus we'll have to remove those. So over here FeSO4, we remove it by reacting it with CaOH twice. Now from this CaOH twice, this OH twice go and react with Fe, forming FeOH twice, and this SO4 over here will go over here and it will form CaSO4. Now both FeOH twice and CaSO4 are not precipitates. That means after doing the first step of the reaction, I got two products and both of these products were not precipitates. I will have to make precipitates out of them. That means I will have to take this FeOH twice, react it with something, make a precipitate out of it. I will also have to take CaSO4, react it with something and make a precipitate out of it. So this first step is just converting FeSO4 to FeOH twice, CaOH twice to CaSO4, and yet both of these are still soluble in water. This OH has a valency of -1 or a charge of -1 of it. Since we have two OHs, the overall charge will be -2. To balance out that charge, my Fe will be having +2. This Ca and SO4 has an overall charge of -2. To balance out that charge, my Ca should have +2. That means still on the product side, I am having Fe2 plus ions and Ca2 plus ions, and both of these ions are contributing to the hardness of the water. Let us see the balancing of this reaction. I have FeSO4. Fe is 1 on the reactant side. I have 1 Fe on the product side. I have 1 SO4 on the reactant side, 1 SO4 on the product side. I have 1 calcium on my reactant side, 1 calcium on the product side. And I have OH2 over here. Also on the product side, I have OH2. Now over here, let us take this FeOH twice over here and react it to form an insoluble precipitate out of it. So I have FeOH twice plus H2O plus O2, giving me FeOH thrice over here. So this is one precipitate which is being formed. This reaction makes this, which is FeOH twice, and this is the overall precipitate out of it which is being formed. Then we have CaSO4 plus Na2CO3. Now from where did we get CaSO4? I have CaSO4 over here. This CaSO4, I am reacting it with Na2CO3, and this forms, this CO3 comes over here forming CaCO3. This CaCO3 is a precipitate over here. That means we can filter out water easily. And this Na2 will react with SO4 forming Na2SO4. Let us see the balancing over here. I have 1 Ca, 1 Ca. I have 1 CO3 group over here, 1 CO3 group over here. I have 2 Nas on the reactant side, 2 Nas on the product side, 1 SO4 on the reactant side, 1 SO4 on the product side. If you see this entire reaction which is happening over here, we first take the soluble part of Fe over here and we convert it into two products. Both of these are still soluble in water. Then we take each of them, form an insoluble precipitate. We take the second of it, form an insoluble precipitate. We filter out the water out of it. That means this water was hard water containing impurities of Fe, is now being converted into soft water which does not contain any impurities either of Fe or Ca, because both of them have been filtered out in the form of precipitates. Now let us see the impurities of aluminium. We have aluminium in the form of all impurities over here. Now aluminium itself has a valency or a charge of it of +3. So to balance it off, I need something which is thrice. For example, let's take an example of AlCl3 over here. Now Cl itself has a charge of -1. But to satisfy aluminium's plus 3, we need 3 Cl minus. Aluminium itself, just one of it has a charge of plus 3. Cl has a charge of minus 1. That's the reason why we will need 3 Cls. That will make minus 1 plus minus 1 plus minus 1, that is minus 3, which will suffice the plus 3. And finally, we get AlCl3, which is balanced out in terms of the charges. The same thing is with Al2So4. Now, Al over here has a charge of plus 3. I have 2 Als over here. That means the overall charge on Al will be plus 6. One Al having charge plus 3. 2 Als will have a charge of plus 6. Why? Plus 3 plus plus 3 will make plus 6. Then I have SO4. Now this SO4 has a charge of 2 minus. If I want to make SO4 to a charge of minus 6, to compensate the plus 6 of 2 Als, I will have to use 3 SO4s over here. And that's the reason why I have written SO4 thrice. So Al2So4 thrice is balanced in terms of charges. AlCl3 is also balanced in terms of charges. Let us take AlCl3 over here. I have taken twice of AlCl3 plus thrice of CaOH twice. Now why I have taken thrice of CaOH twice? Because I know I have this OH group which is going to be attached to my Al over here. Thus it will form twice of AlOH thrice. That means I have 2 Als on the reactant side, 2 Als on the product side. Overall OH on the reactant side is twice into 3. This 2 into 3 is 6. On the product side it is 3 into 2, which is 6. What is remaining over here is calcium and chloride. This calcium and chloride forms CaCl2, that is calcium chloride. Now number of calciums over here are 3. Number of calciums over here are also 3. Number of chlorines over here are 3 into 2, that is 6. This is 2 into 3, that is 6. This is my first reaction over here, where we are trying to make AlCl3 into AlOH thrice plus CaCl2. Now if you all know that AlOH thrice is a precipitate form of it, but not CaCl2. CaCl2 is still a solution form of it. Now if it is in a solution form, that means we have Ca2 plus ions. Why do we have Ca2 plus ions over here? Because it is attached to Cl2. Cl itself has a charge or oxidation state of minus 1. If I have 2 Cls, the oxidation state will be minus 2. That means I have Ca2 plus with Cl2 minus, and this 2 plus and 2 minus cancel off and it will form CaCl2, which is neutral. Now this CaCl2 which is neutral is still soluble in water. That means my water is still hard water. To convert this hard water into soft water, we take this 3 CaCl2 and convert it into thrice of Na2CO3. Now when this 3 CaCl2 reacts with thrice of Na2CO3, what do I get? First thing is NaCl over here. Now I have written 6 NaCl over here because this Na is twice into 3. 2 into 3 on the reactant side is 6. The same is with Cl. Over here also 2 into 3 makes it 6. So I have 6 Nas and 6 Cls forming 6 NaCl. Whatever is remaining over here is CaCO3. Over here I have written 3 CaCO3. Now this CaCO3 is a precipitate form. That means it's a two-step process. In the first step I remove aluminium. In the second step I remove calcium. In the first step this 2 Al plus ions are removed. In the second step this 3 Ca plus ions are removed. Both of them are precipitate. So if I filter out, I will get pure water or soft water, but it will have NaCl into it. And this NaCl is a kind of impurity which can be removed by physical processes. We do not need any chemical processes for it. And plus NaCl itself does not contribute to hardness of water. Next we have Al2So4 thrice. Now SO4 itself has a valency or oxidation state of minus 2. Al has an oxidation state of plus 3. Now since Al has an oxidation state of plus 3, I have 2 Als. That means plus 3 plus plus 3 will make it plus 6. To balance off plus 6, I need minus 6 over here. SO4 just has minus 2. And that is the reason why when I write thrice over here, this minus 2 gets multiplied by 3, which makes it minus 6. minus 6 and plus 6 balance off, and this is Al2 So4 thrice, which is a soluble salt in water. It is a soluble impurity, and because of this Al3 plus ions which contribute to the hardness of water, that water is converted into hard water. We reacted with CaOH twice over here, but we put thrice of CaOH twice because this OH has to come over here to aluminium, and when it comes to aluminium it will form twice of AlOH thrice, and we know that AlOH thrice is nothing but a precipitate form. Now whatever is remaining, we put it as a byproduct. We have 3 Cas and SO4 thrice. Ca and SO4 clubbed together to form CaSO4, and I have 3, so over here I'll have 3 CaSO4. Now because of this 3 CaSO4, I have another impurity generated. Because this is SO4 2 minus, this will be Ca2 plus. This 2 plus and 2 minus will cancel out, and whatever is remaining is CaSO4. But this is still contributing to the hardness of water, because hard water should not have any calcium or calcium 1 plus or 2 plus ions in it. Since it has 2 plus ions in it, we'll have to get rid of this as well. So we take 3 CaSO4 from here and we react it with 3 Na2CO3. Once we react it with 3 Na2CO3, what do we get over here is Na2SO4. This is SO4 over here and this is Na2 over here. We take both of them forming Na2SO4 plus CaCO3 as a precipitate. When I take CaCO3 as a precipitate, it means that this calcium impurity or the calcium ions which were affecting the hardness of water are completely removed. So what is remaining over here is Na, which is 2 into 3, 6 on the reactant side, 2 into 3, 6 on the product side. And I have SO4 over here, 1 SO4 on the reactant side, 1 SO4 on the product side. Now the last type of reaction which we are going to study is about the sodium salts over here. We should understand that not all sodium salts contribute to the hardness of water. But when certain sodium salts which are amalgamated or which are mixed with aluminium or ferrous, then those sodium salts will lead to hardness of water. And such salts need to be addressed. Over here I have NaAlO2. So over here I have sodium aluminium oxide. Now when I have my NaAlO2 reacting with twice of H2O, it will form AlOH thrice, which is a precipitate, and NaOH. Now if you all see, I also have NaOH forming a byproduct over here. But we are not going to address this NaOH because NaOH will not contribute to hardness of water. But NaAlO2 will contribute to the hardness of water. We should understand that which sodium salts provide hardness of water and which sodium alkalis or another salts will not provide. For example, if I have NaCl over here, then we will not address NaCl because NaCl will not contribute to hardness of water. When sodium reacts with either iron or aluminium or any other such metals, it forms a salt which gives hardness of water. And that's the reason why we have to convert it into some precipitate and take out of them. Over here, if you see, the precipitate over here is AlOH thrice. Now this AlOH thrice does not even contain sodium in it. Sodium forms a byproduct of NaOH which will still remain in water, and still that water will be soft water. So over here our main aim is to remove these heavy metals out from sodium. So I have NaAlO2 plus twice of H2O forming AlOH thrice, which is a precipitate, plus NaOH. Let us see the balancing of this entire reaction. The number of NAs on the reactant side is 1. The number of NAs on the product side is 1. The number of Al on the reactant side is 1. The number of Al on the product side is also 1. Now let us count the number of oxygens. Over here I have 2 plus 2, 4 oxygens. Over here I have 3 plus 1, 4 oxygens. And over here the number of hydrogens are 2 into 2, 4. And over here also I have 3 plus 1, 4 oxygens. That means this entire reaction is my balanced reaction. So in this session we studied about all the elements which were metals. For example, we studied Fe, we studied aluminium, we studied sodium, and all the metals which contribute to the hardness of water. We studied the different reactions of iron, we studied the different reactions of aluminium, and we studied some reactions of sodium in which some of the salts give hardness of water and some of them do not give hardness of water. With this, we complete all the reactions which are required in the numericals to convert hard water into soft water, especially by using the lime soda process. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.